All right, ladies and gentlemen, I'm with Miss Johnson here. This is Mr. Berman for you Johnson kids. We're talking about the 3-3 while we are in D.C. enjoying ourselves with the 8th graders. Good
Maybe.
stuff.
Hopefully.
We'll be wide awake for sure.
Yes.
So we're talking about how the rate of change and slope are going to help us with Chapter 3's Section 3. So big key concepts you see on the left-hand side. Slope is the same thing as the rate of change. We're talking about the rise over the run, or the vertical change over the horizontal change. Make sure you write that stuff in your notes. If you need time, pause it, because we'll keep going quickly.
Pause it up.
Pause it up. So example numero uno is for us to be able to find the slope from just having 2 points. So the big thing here, Ms. Johnson, is to do what?
You read your line from left to right, so you start at the left side of the line and you move up the line until you come to your first point. Then you're going to look at, do I have to rise up or lower down to get to the next point? So the rising up would mean that you would start at that point and rise up how many units, Mr. Berman?
Let's see, 1, 2, 3, 4 for me to get on the same line that the horizontal line is. So I went up 4. I'm going to put a number 4 here just to keep my brain straight. I went up 4. And then it looks like to get over to this point we had to stay on the path here 1. And we went to the right 2. Is that a positive 2 or is that a negative 2?
It's a positive 2. The run generally is the positive number. It's the vertical change and the horizontal change that determines whether or not your slope is going to be positive or negative.
So when we had our rise of 4 over our run of 2, that looks like something I can probably fix. 4 over 2 simplifies to a 2. So that means my slope is 2?
That is correct.
Sweet.
And it's a positive 2.
I love it. Woo! We got more.
We got more.
I love having more.
So where do we start, Mr. Berman?
I think you said if we read from left to right, that would be the smartest way. So it looks like if we go right here, we have the point of -3, 0. And it looks like it's kind of going downward. That might be a negative thing.
Yeah.
So let's count. We're going to stay on the path. 1, 2. I had a down of 2. Is that a positive?
No, going down is a negative thing.
Oh, kind of like my bank account. If it goes down, that's a bad thing, I guess.
Yeah, well.
That's what happens.
Now run over to the line.
1, 2, 3.
You're
Yay!
there.
Perfect. So I ran over to my line. Slope is rise. Oh, beautiful handwriting.
Over the run.
Over the run. So we rose.
And actually we went down 2 units, so that rise really was going down or descending 2 units.
That's kind of like falling.
But not in love.
Not. So if I went down 2 and a run of 3, that means my slope is a -2/3.
And we ran 3 units. Once again, we are always running, but we're not running in a negative fashion. It's really the going up and down that determines whether or not. So it's really the rise that will give your line or your slope that positive or that negative value.
And that's, of course, especially as we read from left to right. If you read it the other way, it's going to change things.
Yeah, we don't want that. And we want to be consistent because math is the pattern of, or the science of patterns and symbols. Our pattern is what's going to keep us going in the right direction. If we change patterns, then we're going to do things wrong.
Be confusing. Let's go with my favorite color is blue. Woohoo! So if we read from left to right, my rise,
Is 0.
I can't find one.
You got to rise, but it's 0.
That's not a good thing.
I'm not going up or down, so I'm staying where I'm at, so we're going to call that rise 0.
0 to hero. That's going to be how quickly we go. Uh-oh, I screwed up on writing. Don't tell Miss Johnson she didn't see it. Oh, safe.
What am I, blind? I'm old, but I'm not blind. Okay,
we're
Berman?
not that old. And we run 2 spots. So
Yep.
my run was to the right 2. I don't even know what 0 divided by 2 is.
Well, you can divide 0 by 2
Oh,
because you have a positive denominator. Your run is positive. So really, your answer just simplifies to 0.
so my slope is 0. Ew. That means my horizontal lines have a slope of 0.
All horizontal lines have a slope of 0.
So that might be important for me to write down in my notes.
If you're writing down your notes,
Okay, well, I'm not going to write it down in my notes. I'm smart. I hope the kids do, though.
well, okay.
Am I smart?
Well, if you're writing down stuff, which you are, so.
Okay, good. Whew. Nervous.
Ooh, this one. Ooh.
Okay, so it looks like my rise. Which one do I start with? I'm reading from left to right, and they're
Oh
both.
boy, you have an issue.
Okay, well, I'm just going to start with the bottom one because that's
Okay.
kind of fun. So a rise of 1, 2, 3, 4, 5. I like to be positive, so I wanted to rise 5.
Oh yeah, that makes sense.
Uh-huh. And then my run to get from,
There is no run, because run is movement from left to right.
so,
I can't run left or right.
well, not on that line.
No, I can't. I got a problem with this one
Yeah, my
because
calculator says things like I can't do that.
you're right. You cannot divide by 0.
What does that mean? So, like, old people a long time ago called this something?
I believe that they called this undefined or no slope. I cannot divide a fraction by 0, so technically slope is considered a 0 or is considered a fraction. So this thing is no slope. It's like slope is a line that you can walk on or climb on, but I can't walk on this line. It's like walking into a wall. Unless I'm Spider-Man, I'm not going to be able to walk on this line.
What if you were like Wolverine? Could you go through that wall?
Can Wolverine go through a wall?
I don't know. He's got claws.
Maybe he could claw his way through that line.
That'd be pretty sweet.
Yeah.
Uh-oh, we don't have points anymore. But we do have points.
I've got skills.
To pay my bills or just your own?
I ain't paying any of your bills.
That sucks. Okay, so we're going to graph these points. You guys remember how to graph, right?
Yes.
First one's X, second one's Y. That means I go to the left 2, and then I go up 1, put a point. To the right 1, 2, 3, 4, 5, and then up 7. 1, 2, 3, 4, 5, 6. Oh my goodness. How do I connect the dots? I'm going to be a purplish. If I had a ruler, I sure would use a ruler.
Or if you had a line, which you kind of do at the top of that thing.
Oh, should I do that instead? Miss Johnson, you're way smarter than me. Uh-oh. Don't tell the other kids. Here's a line. Look. Whoop.
All right.
I'm adding arrows with this, though.
Because the line goes on forever in each direction.
Yeah, that's important.
Yep.
So, how far up did I go? Let's change colors again. That's red this time. 1, 2, 3, 4, 5, 6. I went up 6. So up 6, and then my run was 1, 2, 3, 4, 5, 6, 7. So then my slope would have to be what?
6 over 7. And it's positive.
Oh yeah, it went up.
Yeah, and when you read your line from left to right, you'll notice that your line is going up. And so that's how you can see that it's a positive line, because when you start at the lower side and you end at the higher side, so to speak, when you follow your line, you know it's a positively sloped line.
Yeah. I like to think of money. If that was my bank account, I'd be a lot happier than what my bank account really looks like.
Yeah, kids will do that.
Yeah. Darn kids. So how do I graph this one?
Plot your points.
To the right 2, up 1, 2, 3, 4, 5. To the right 4, 3, 4, up 7. 1, 2, 3, 4, 5, 6, 7.
Wow, this is another positively sloped line.
I never would have guessed that. Yep. Gosh, this could get more exciting. I don't know how, but it could.
Well, if I were to sing,
Sing us a song, Miss Johnson. Sing us a song.
you went up 2,
Okay.
you went over 2, and
So then 2 over 2 simplifies.
Berman, I think you just cut me off, but go ahead.
Oh, come on. I don't cut people off. 2 over 2 simplifies to be just 1. So then the slope is a 1 as a whole number.
Hey, does that mean that, what does that mean? I mean, okay, so slope can be a whole number?
Yeah, like if I have a whole number, that's like saying that I have something over 1. So if the whole number was 2, I could have 2 over 1, which means my rise is 2. So let's change that so it says it 2. So this is just a what if. If my slope was the whole number of 2 over 1, that means I rise 2 and I run 1.
Okay, so slope can be whole numbers.
Yeah. Slope can also be like improper fractions. So if I had an improper fraction of maybe like a 3 over 2, I don't want to change that to be 1.5.
Why not?
Because then I know that it rises 3 and it runs 2. And that's a heck of a lot easier for me than to say a 1.5, it rises to the run of 1.
Yeah, I guess even if you wrote it as 1.5, you lose that rise over run because you got that extra number in there.
And it's super confusing.
Yeah, I don't like that. I don't like to be confused. You probably have to deal with it on a day-to-day basis.
Yeah, one time I wasn't even able to
Okay,
find.
let's get on.
Okay. Well, here's the another way of us finding slope. If
No
we don't,
pictures, no graphs. Where are the graphs, Mr. Berman? What could I do? Oh my gosh, I'm so confused.
Well, most of the time when I'm trying to find slope of things or the change of y over the change in x, I don't have graph paper, so I don't get to graph it. So we have a process here, and I'll show you guys this first one, and Ms. Johnson will talk about the second process. If I label my ordered pairs as a y1 and an x1 for the first point, and the second point says the x2 and a y2, I can plug them into this formula and figure out the slope very, very quickly. So y2 was 7, so I'm just plugging it in. And y1 was 1, so 7 minus 1 over x2 was a 5, and x1 is a negative 2, so minus a negative 2. So if I do this math, 7 minus 1 is a 6, 5 minus a minus, remember that we do the keep, change, change, so minus a minus turns into a plus, plus. So this becomes a 6 over 7. My slope is 6/7.
I have a better way of doing it.
Okay, well you show us your better way of doing
Okay.
it then.
I sometimes get confused when I've got to do x2 and y2 and all that kind of stuff. So my way is just to list the 2 points vertically. 2, 5, and 4, 7. Now I know that the rise is always the change in the y's, and change means minus. So what I'm going to do is I'm going to work on the right-hand side with my 2 y numbers. And I can either subtract in either direction. I like to go 7 minus 5 though. So let's subtract upward and draw our arrow upward. Now your numerator is 7 minus 5. And that's the change in your y values. And if I subtract upward on the right side, I have to go in the same direction on the other side.
That sounds
so
fair.
4 minus 2 becomes your run, or your change in your y or x values. So this slope is 2 over 2, which simplifies to 1.
Oh, sweet. That seems pretty easy.
Yeah, so I think really, depending on who you are and what your preference is, you could do either way, and as long as you do your math correctly, you'll get the correct answer.
Are you sure?
Yeah.
Okay, good. We have one last example here. It's the easy ones.
That's a lot of words.
Oh my gosh, that's scary.
I don't like doing word problems, so I'm just going to skip this one.
Okay, let's skip it. Saik, I was just kidding. We don't skip
Good
those.
one, yeah.
Oh, who skips things? Remember dependent variables from chapter what?
0?
0?
No. That was a joke.
Oh. Did we talk about those?
Yeah, we did. Their dependent variables are the x values.
Oh, these are X's?
Yeah.
Are you sure?
Are they?
I don't know. Pretty sure they're the Y's.
You're right.
Okay, good. Whew! Good thing you're such a jokester.
Good thing I am.
My pen's not working. Don't tell anyone. So I always remember that the time is usually on what axis?
That is usually on the x-axis.
Okay,
Okay?
because the number of days wouldn't depend on the rental charge.
You know, rental charges can change. One day is no different in time as any other day. They're all 24 hours.
So what's the change from 60 to 75?
15.
Oh,
Do
that's
you not know that?
I'm curious. So since the charge depends on the number of days that you rent a car, my change, as you can see, from here to here, from here to here, from here to here, from here to here,
Yeah.
is 15 every time, right?
And that makes sense because the more days, the more you're gonna, yeah,
Yeah, you're more gonna have to pay.
yeah,
So the change in the dependent variable, how much you get charged, is $15.
yeah,
And then from day 1 to day 2 to day 3 to day 4 to day 5, that's just a change of 1.
yeah,
So it costs an extra $15 per day, right?
yeah.
So what is my change then?
Your change is 15.
So that means that my slope is $15 per day?
Yeah, because it's constant.
Okay, perfect.
You know, a constant slope means that you have a straight line. Because if you didn't have a constant slope and say you graph these points, you would see no straight line. If the rental charge changed every day, then you potentially could run into issues.
Yeah, your line will look like this, and then I wouldn't probably rent from that company if it costs more for.
No, no.
That's kind of weird.
Yeah.
So are we all done here?
No, because there's part B.
Ah, shoot! I can't skip part B either.
No, you can't.
Find the rate of change
Even
using.
though it's words.
But words I always skip. Day 5 to day 2.
Oh, okay.
So day 5 to day 2, that's like 3 days, isn't it?
Yeah,
Okay.
that is.
So that's on my bottom.
Yeah, it is because that's your dependent or independent variable, sorry. And 5 minus 2 is 3.
Okay. So from 120 to then 75, that's a change of how much?
Where's my calculator? Oh, wait, I have a brain.
Oh, the calculator
yeah, okay.
I think that's 45.
Yeah, it is.
Okay, good. What's 45 divided by 3?
It's 15.
Oh my gosh.
Once
it's,
again, I have a brain. I don't have a calculator.
It's constant. I love it when things are constant.
Yeah,
Is this your assignment for your kids too?
sure.
Sure.
What the heck?
I'd check Miss Johnson's calendar on her website to make sure, but
I would too, but who knows?